In this video, I'll be providing the solution to 2022 JAMB examination question 11 to 20. Question 11 here says, calculate the force on a 5-meter long stiff wire carrying a current of 8 amperes and lying in a direction at 30 degrees to a magnetic field of magnetic flux density 0.6 Tesla. A 30 Newton, B 10 Newton, C 12 Newton, D 15 Newton. So how do we solve this question? The first thing you want to notice is that this question is under magnetic field. And for magnetic field, we said the force on a conductor carrying current, question number 11, the force on a conductor carrying current F is equal to I L B then sine theta. Okay, where I is current, all right? I is current. From the question here, the value of the current here is 8 amperes. That's 8 amperes. L is simply the length of the conductor or length of the wire in this case. And the value of the length, let's see how many, 5 meters long. So L is 5. B is your magnetic field, all right? And the value here is B is the magnetic flux density, all right? And the value here is 0.6 Tesla. So B is magnetic MAG flux density. And the value of B here is simply 0.6. It's measured in Tesla. So 0.6 Tesla, you have this. And then the angle theta is 30 degrees. So theta in this question is equal to 30 degrees. Let's use the values here. From here, the force F will be equal to I, 8 times L, 5 times 0.6. So 8 times 5 times 0.6, this is in meters. 8 times 5 times 0.6. Then sine of the angle there is 30. Okay, so F is equal to, let's multiply this. So I'll get my calculator. I'll punch 8 times 5 times 0.6 times sine of 30. My answer here is 12. So this becomes 12. Don't forget that F means force, and force is measured in Newton. So you have this. So the value here, F, is equal to 12 Newton, which is option number C. So we have this. Okay. Next up, number 12. 12 says, which of the following is correct about an electric cell? A, primary cell produces a large current for a long time. B, secondary cell has a very high internal resistance. C, primary cells have a very low internal resistance. D, secondary cells have a very low internal resistance. Now you want to note this about electric cells. Let's start with primary cells. Primary cells are used up gradually. Often the cells are used and can't be recharged. All right, so primary cells can't be recharged. Meanwhile, secondary cells or accumulated can be recharged and used for a long period of time. And their main advantage is that they have very low internal resistance. So in essence, secondary cells have very low internal resistance, which is D. So the correct option here is option D, that secondary cells have very low internal resistance. Okay, question number 13. Which of the following operations can be used to convert an alternative current dynamo into a direct current dynamo? A, number of turns in the coil is increased. B, strength of the field magnet is increased. C, slip rings are replaced by split ring accumulator. D, coil is wound on a soft iron armature. Now, what's the answer to this question? Now, this question here is under DC generators. Here's something to note. A DC generator is one in which its current is allowed to flow in one direction, even though it may vary in value. Meanwhile, an AC generator can only be made to produce a DC by replacing two slip rings with a single split ring or accumulator? So the answer here would be option C. All right. The slip rings are replaced with split ring accumulator. That is the correct option. Question number 14. The net capacitance in the circuit above is, we want to find the equivalent or net capacitance here. How do we solve this? Now, for this question here, you'd have to resolve this to a single capacitor or capacitance. You have three capacitors here, 1, 2, and 3, right? This having 2 microfarad, this having 2 microfarad, this having 4 microfarad. Now, how do you resolve this? You start with these two, 1, 2. Of course, they're in parallel. So resolve them in parallel. Take the answer and resolve this in series. So let's resolve. Let's call this C1. Let's call this C2. Let's call this C3. Now, how do you solve this? First, C1 and C2 are in parallel. So C1, this is question number what? Question number 14. So for question 14, you have that C1 and C2 are in parallel. All right, if they're in parallel, let's say this C1 this way. If they're in parallel, the equivalent C1 to C1, 2 is equal to C1 plus C2. So you want to know that capacitors in parallel is added straight up like this. The value here is 2 microfarad, 2 microfarad. That becomes 2 plus 2, same unit, that becomes 4 in microfarad. So the equivalent C of 1 and 2 is 4 microfarad. Now, this 4 microfarad here, if you resolve these two, you'd have it like this. So starting from this end here, you have this end. The value of C12, this is straight like this, straight. You have C12, which is 4 microfarad. That's these two resolved. Then you have this, which is this part here. Then you have C3. So you have this C3, and then you have this. You want to know that C3 is also this value here, which is 4 microfarad. So 4 microfarad. So from here, we can see that C12 and C3 are in series. So we can say also C12 and C3 are in series. How do we get the equivalent? For this here, we can see that the equivalent is given by 1 all over, that's the inverse of C net. So we have to find the net capacitance. That's equal to 1 all over C12. We'll take inverse plus 1 all over C3. All right. So this is how you find equivalence for capacitors in series. I have 1 all over C net is equal to 1 all over, this value is 4, plus 1 all over, this value here is 4. From here, I have 1 all over C net is equal to, if you sum this, 1 over 4 plus 1 over 4 gives you 2 over 4. So you take inverse. This one goes up, this comes down, becomes C net all over 1 is equal to, this goes up, 2 goes down. That becomes 4 over 2. So work on this from here. 2 here, 1, 2 here, 2. So the net capacitance is equal to 2 microfarad. The answer there is 2 microfarad. Let's see, that's option D, 2 microfarad. So you have this. All right. So this is how we solve this. You want to take note that the way we solve capacitors in parallel is opposite the way we solve resistors in parallel. I've explained that in our previous class. I'll leave a link in the video description. Question number 15. A body, when slightly displaced, is said to be in neutral equilibrium only if it tends to A. Come to rest in a new position with the center of gravity and height remaining unchanged. B. Return to its position. C. Remain in its displaced position. D. Move further away from its original position while its center of mass changes. Now, for question number 15, you want to note that If a body is slightly displaced for neutral equilibrium, it tends to come to rest in a new position. For such body to return to its original position, it is in stable equilibrium, and for it to remain in its displaced position, it means no displacement has occurred. If it moves further away from its original position, it is in unstable equilibrium. Hence, the correct answer for neutral equilibrium is that it tends to come to rest in a new position and the height remains unchanged. So that means the correct option here is A. It comes to rest in a new position and the center of gravity and height remains unchanged. That's the answer to this question. Question number 16. The instrument to measure the relative density of light is A. Thermometer, B. Hydrometer, C. Spring balance, D. Beakers. All right. Question 16. The instrument to measure the relative density of light is A. Thermometer, B. Hydrometer, C. Spring balance, D. Beakers. All right. Let's analyze each of these instruments one after the other. First things first, thermometer is used to measure the temperature of a body. The hydrometer is used to measure relative density of liquid. The spring balance is used to measure the weight of an object, while beakers is simply used to measure the volume of liquids in a lab. So they asked for the instrument used to measure relative density of light. The answer here is the hydrometer. So the answer there is B, hydrometer. Question number 17. The maximum kinetic energy of a simple pendulum of the simple pendulum below occurs when the bulb is at what position? So you have this. Now let's analyze this question here. Let's take this. So you have this. Let's say you have a ball here like this. If I choose to push this ball, right, with a certain speed, this ball goes up to a point. Let's call it point A. It goes up to point A. It stops at A. It comes back to this. Let's call this B. And from B, it swings to C. Let's call this C. Stops at C, swings back to B. Then from B, it goes to A. You want to note something. At point A, the ball stops moving. At this point here, A, this point here, A, the ball stops moving. Hence, its kinetic energy here is equal to what? There, 0. Again, it swings to B, then from B, it swings to C. At point C, what happens? It stops swinging and then starts coming back. That means at point C there, the kinetic energy is equal to what there? 0. But B is the part at point B. It's from B that it swings to A, and then from A, stops, comes back to B, and from B, it goes to C. In essence, B is the point that changes the direction from A to C. So this is where kinetic energy is maximum. Right? So at B, kinetic energy is maximum. So the maximum is at the center there, which is 3. So for this question here, question number 17, the correct answer is option C, which is 3. That's this. All right. If they ask you the position for zero kinetic energy or the minimum kinetic energy, you have two positions, A and C, which in this case will be what there? 1 and 5. So 1 and 5 will have the minimum kinetic energy. Meanwhile, the maximum will be at the center, option B, which is number 3. Okay, question number 18. Let's look at question number 18. Question 18, from the diagram above, calculate, that's this one here below, in this case, calculate the total current in the circuit. So you have this. You have voltage, you have I, current, then you have 3 resistors, this one's here. You ask to find the total current in this circuit. Now, how do we solve this? To solve this, your first task would be resolve these 3 here to give you 1 resistor. In essence, find the equivalent. The equivalent resistance here, question number 18. The equivalent resistance here, 1 all over R, is equal to 1 all over, since they are in parallel, I will take inverse. So 1 over 18 plus 1 over 12 plus 1 over 6. 1 over 18 plus 1 over 12 plus 1 over 6. Let's get this done. 1 all over R is equal to So if I take my LCM here will be 36. 36. Now 36 divided by 18 gives you 2. 2 times 1 here gives you 2, plus 36 divided by 12 gives you 3. 3 times 1 here gives you 3, plus 36 divided by 3 by 6 here gives you 6. 6 times the 1 above gives you 6. Working on this, I have 1 over r is equal to 2 plus 3 is 5. 5 plus 3, 5 plus 6 is 11. 11 all over 36. From here, for us to get the value of r, I'll simply take inverse. So if you take inverse here, this goes up, r goes up, 1 comes down. That becomes r over 1 is equal to 36 goes up, 11 comes down, 36 all over 11. So the value of r here is equal to 36 all over 11, of course, in ohms. So we have this already. Now, again, they said we should calculate the total current in the circuit. Let's get this in decimal places. So 36 divided by 11. If we punch that, 36 over 11, if you punch that, your value is 3.272. So this is 3.272 or 3, yes, approximately in ohms. So you have this. We have to find current. We are given voltage there. Recall that from Ohm's law, V is equal to I times R. To get the value of I, I'll divide and divide here by R divided by R. This cancels this. So current is equal to V all over R, and that's equal to, what's the value of V from the question there? It says 12 volts. So that becomes 12. So that becomes voltage 12 all over R. The value of R here is 3.273. Let's get this done. So I is equal to 12 divided by 3.273, and that gives you about 3.666, which is approximately 3.7. Current is in amperes. So let's see 3.67 or 3.7, any of them. All right, that's option B, 3.7 amperes. You have this. Question number 19. The volume of a fixed mass of gas is this 10 cm cube when its pressure is 40 centimeter mercury, that's cmHg. Find the volume of the gas when its pressure is 200 cmHg, which is centimeter mercury. Now, how do we solve this question here? To solve question number 19, we need to recall Boyle's law, right? So I'll take this off and let's solve this using Boyle's law. From Boyle's law, you want to recall that P1 V1 is equal to P2 V2. In 19, you were told that the volume of a fixed mass of gas is 10 cm cube. That means V1, which is this, is 10. So this is V1 cm cube. They said when its pressure is 400. So P1 is 400. So I'll have 400 here. So P1 400, V1 10. All right, let's proceed. It's equal to P2 V2. You ask to find the volume, that's V2, of the gas when its pressure is 200 cm. So you have when P2 is now 200, what's the value of V2 basically? All right. So to solve this question, just divide here by 200, divide here by 200, and let's get the value of V2. From here, V2 it's equal to 200 divided by 400, you have 2. 2 times 10, you have 20. So you have this as 20. The unit here is cm cube, because if you look at this, the volume here was in cm cube. Again, observe that we did not convert because this is in cm cube and this is in cm. So we didn't have to convert, right? The answer there is this one here, 20 cm cube. That's option D, 20 cm cube. All right, next up, question 20, the last one for today. The last one for this session, question 20 says, under what conditions are cathode rays produced in a discharge tube? All right. A, high pressure and low voltage. B, high pressure and high voltage. C, low pressure and low voltage. D, low pressure and high voltage. For number 20, you want to note that cathode rays are produced in a discharge tube under low pressure and high voltage. And I think this is actually one of the most repeated JAMB questions. Okay, so you want to note that the correct option here is that cathode rays are produced in a discharge tube under low pressure and high voltage. So low pressure and high voltage is option D. That's the correct answer. All right. All right, guys. So question number 21 is for you. You try question number 21 and leave your answer in the comment section, and I'll tell you if you're correct or not. The question here, 21, says, so question number 21 says, for correcting long sight defects in the human eye, we require A, converging lens, B, diverging lens, C, microscope, D, periscope. All right. What is the answer to this question? Leave your answer in the comment section. Is it A, B, C, or D? Leave your answer in the comment section and I'll give you a reply. I will tell you if you're correct or not. All right. Okay, guys. So please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.journalemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comment, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.